PA56 part 5, that is the last section of this authorization server availability, and in this section we are going to talk about open redirector. So what is open redirector vulnerability? So an open redirector vulnerability occurs when an authorization server allows redirecting users to any arbitrary URL without proper validation. We have seen, right, when we talked about redirect URI manipulation, that if the attacker is sending some crafted address to the any authorization server, if they are not doing the proper validation, yeah, in that case user can be redirected to some other malicious website. Correct. So I think we already discussed multiple times this part. So this flaw can be exploited by attackers to mislead users or steal sensitive information such as tokens, codes, or credentials during the OAuth or OpenID Connect flow. So let's see how this vulnerability happens. So there is redirect URI manipulation. We already know this. So the attacker alters the redirect URI parameter in an authorization request to point to their malicious website. The authorization server does not verify the legitimacy of the redirect URI, and in that case, once authentication has been done, the users are redirected to the malicious site instead of the legitimate application. This is one of the problem. Another is use of fragments or referrer headers. Again, we discuss also this part. So sensitive information like access token or error details might leak through URL fragments or referrer headers to the malicious site, especially during redirection. So we already discussed this two part, like redirect URI manipulation and fragments part in our previous section, that how using fragments or referrer headers or redirect URI manipulation, how this using these things users can be redirected to some other malicious site instead of the legitimate application. And why this is happening? Because maybe the authorization server is not doing the proper validation. Right. Consequences is like phishing attacks. Users are redirected to fake website that mimic legitimate ones, where attackers can steal login credentials or other sensitive information. This is a very basic thing. I think it is not about only OAuth OpenID Connect. In general, also you see that maybe you heard that you're trying to access some banking website, and by mistake you click some link and it seems to be look like a banking website, and you see a login page, you enter the ID and password, and yeah, that it's not a legitimate website, and they just steal your credentials, and yeah, it can be theft then, maybe if MFA is not there, like that, yeah. So those things are still maybe earlier also happened. Token or authorization code theft. So attackers intercept tokens or authorization codes sent to the malicious redirect URI and use them to access the victim resources. User confusion and trust issues. Users might lose trust in the legitimate platform if they are redirected to malicious or suspicious sites. That is also true. Malware distribution. So redirects can lead to malicious sites that deliver malware or spyware to users' devices. So examples of exploitation. Crafted malicious link. So you can see the attacker sends a crafted URL like something this, authserver.com authorized client ID and redirect URI something like this. When the user click the link, authenticates and logs in, they are redirected to attacker's malicious site. Because here the redirect URI validation has not done properly at the authorization server. So the user authenticated and then land to some other attacker's malicious site, not to the legitimate application. Token interception via open redirects. The malicious site intercepts sensitive tokens or codes during redirection and use them to impersonate the user. Prevention based practices, and how we can prevent this. So strict redirect URI validation. Only allow redirect URIs that are pre-registered and match exactly with the client application configuration. Avoid allowing dynamic or user control redirect URIs. Again, we discussed this part in previous sections. Use of exact matches. Enforce strict URI comparison to prevent partial matches with malicious sites. Logging and monitoring. Log all redirect URI uses and monitor for suspicious patterns or unusual redirects. Investigate repeated use of unregistered or invalid URIs. Once you just design these things, in that case also you need to keep monitoring. So you need to design or build something which can keep monitoring these tracks, so that you can just stop those attacks and yeah, prevent your client from those attacks. Limited sensitive data exposure. Do not include sensitive information like tokens or authorization codes in URL fragments or query parameters. Use post request or secure cookie storage for sensitive data transmission. We need to definitely use this part whenever we are using we're passing any sensitive data. We already know that use of TLS and yeah, transport layer security when we need to use whenever we are transferring some message. And yeah, we are not supposed to include any sensitive information in the URL fragment or the query parameter, as we have seen like in the section that how you can pass the access token in the query parameter and get access to the APIs, but there is a risk in that. Okay, we already discussed that, yeah, because yeah, if you're passing that in the URL, right, so it can be like uh, yeah, there is a way like this can be stolen. But if you're passing that access token in the authorization header, yeah, there is no problem in that. Yeah, you can just prevent that by passing the access token in the authorization header when calling the APIs, not by passing in the URL in the query parameter. We already seen that in the previous sections. Whitelist trusted domains. Whitelist trusted domains, sorry. Create a list of trusted domains or base URIs and allow redirects only to these domains. Block any attempt to redirect to unknown or untrusted domains. Yeah, if you're working in any industry, you have some specified domains. Just allow that only. If something coming apart from that, just block them. Secure error handling. When error occur, avoid exposing sensitive information in the URL like error details or tokens. Never we need to expose this part. Redirect users to a neutral and secure error page. So yeah, error handling is again very important thing whenever you're designing these solutions, because you need to, if you are exposing some correct information directly, yeah, it can be theft. You don't know who is accessing. Maybe attacker is just trying to test your system and then just see by just getting those error, maybe it can do something, right? Go for the next step. So we are not supposed to expose any information, sensitive information in the error while error handling, while error happening, right? Use PKC. Require PKC in authorization process to secure the exchange of codes and reduce the impact of intercepted tokens. So what are the key takeaways here? Open redirect vulnerabilities can lead to phishing, token theft, and user impersonation. Proper validation of redirect UI is the most effective way to mitigate this risk. Sensitive data should not be exposed through URLs, fragments, or referrer headers. Constantly monitor and log redirect activity for potential misuse. By implementing these measures, you can significantly reduce the risk of open redirector vulnerabilities in your authorization server. Handling open redirector vulnerabilities. What are the risks? When dealing with open redirect vulnerabilities, sensitive information such as tokens or user data can accidentally get exposed. This can happen in two key ways we have seen. One is URL fragment. URL fragment are the part of the URL after the hash symbol. We already discussed parts. So some browsers or system might unintentionally send fragments like access token to external website. Third-party tools or extensions. An attacker could intercept tokens from the redirected URLs and misuse them. Another is the referrer headers. The referrer header automatically shares the URL of the previous page with the next one when a user navigates to new page. You can just see this part like when you access some application, just check that, open some tracer in developer tools and you can able to see those part like how the referrer header is just automatically shares the URL of the previous page when you're navigating to the next page. If the previous page URL contains any sensitive data, this data might be visible to the destination page, including untrusted sites, and fall into the hands of attackers if the redirect is insecure. Because by it's a phishing technique, right? By mistake you click something, and through the referrer header that your sensitive information sent to the malicious sites, to the attacker site, and the malicious site could extract tokens or sensitive details from the referrer header. Why does this matter for open redirectors? When authorization servers redirect users to untrusted or malicious site, these sites could unintentionally gain access to the sensitive data, and this could lead to exposure of sensitive information, that is access token error details, security breaches. Attackers could misuse this data to impersonate users or access resources. Okay, how to prevent? Avoid putting sensitive data in the URL fragments or query parameters. Use HTTP only cookie to store tokens. Transmit data using post requests instead of appending into the URLs. Sanitize referrer headers. Strip sensitive data out of the URLs before any redirection occurs. Ensure that the referrer headers do not contain tokens or personal information. Restrict open redirects. Only allow redirection to trusted pre-approved URLs. Validate and whitelist redirect URLs when during the workflows. Okay, so all these things we're putting like, yeah, you can just avoid this. You can mitigate this vulnerability. Key takeaway is implementing secure redirect practices is critical to protecting user data and preventing exploitation of open redirector vulnerabilities. By avoiding risky URL handling and restriction redirection targets, you can significantly reduce security risk. Yeah, as I told you, you can't make any system 100% secure, but by implementing these checks, at least you can reduce. Like checks is like checking validation of redirect URIs, defining pre-approved the domains, right? Uh, Authorization server has to do the validation of the redirect URI like coming in the request. with that in the token request, yeah, that's a match to just avoid that token generation thing. If some attacker is trying to use the authorization code, right? Don't no need to pass the access token in the query parameter. Always use that. Use just pass like the authorization bearer header in the HTTP post request. Use TLS, right? All those things we need to ensure. We need to keep to make our system solutions more secure, and we need to make our system because we are just building the security solution. So if we are not giving the importance to these things, we will make our system, our solutions vulnerable. And then how the application user can able to, yeah, how we can ensure that user can able to access the applications without any issues, without any security breaches and all. So definitely we need to ensure that these all things needs to be checked, yeah, before making these solutions live. Okay, there are many tools available right now in the market which can use to test all those, but yeah, still we need to know so that we can do the validation, or maybe yeah, just check while building and designing the solution. So yeah, we end this like session, and let's jump to the last section, that is token vulnerability. So we can just understand like how token can be vulnerable, and what ways can we how we can prevent those, like by getting like it's again like maybe few things will repeat, but yeah, let's go through that. And then yeah, as I told, we there are many things need to be covered on the PingFed side, like the REST APIs, like then we have some troubleshootings are there, like some implementations are there, token exchanges pending, and then we will talk about some policies also, like how we can build those, because you have now understanding like in the ping federate how to build the policy fragments, adapters, PCVs, data store, whatever, right? So I will just try to discuss on few good implementations. Maybe I'll just show you, and maybe you can build in your own lab and just do those practices. Okay, so thank you, and if you have anything, please put in the comment section.